In the practice problems, there's a number of situations in which you're supposed to take a limit, turn it into an integral, and then evaluate the integral. The thing that we have to keep in mind is that this is the definition of the definite integral. If we use equally sized subintervals and choose our representative CI's to be the right-hand end of those intervals, then CI is going to be a plus I times delta x. In one of these limits, then, if I see something that looks like this, that's very suggestive. That's 14 plus I times 23 over n. I'll interpret the 14 as being a, the left-hand end of the interval, and the delta x is the thing that gets multiplied by the I. The moment that I know that, I can figure out the upper limit of integration. B is x number n, which is a plus n delta x. In this case, that would be 14 plus n multiplied by 23 over n. The n's cancel out. 14 plus 23 is 37. So this would tell me the upper limit of integration. For example, we'll look at the limit of the sum of 3 multiplied by 4 plus 5i over n times 2 over n. The thing to lock in on is the 4 plus 5i over n. I'm going to think of that as being x number I, telling me that the a has to be 4 and the delta x has to be 5 over n. As we said, this immediately tells me how to get our hands on b. b works out to be 9. At the end of the product in the sum, we have a 2 over n. Delta x, though, is 5 over n. That's no problem. 2 over n is 2/5 times 5 over n. That factor of 2 over n is just 2/5 times delta x. So when I write down the limit of the sum, I'll think of this as being 3 times x number I times 2/5 times delta x. 3 times 2/5 is 6/5. Limit of the sum, integral sign, delta x turns into dx. The thing that you are integrating is 6/5 times x. And then you can evaluate that in the usual way. In this limit problem, there's more than one candidate for the CI. I have a constant plus 2 over n times I inside the cubing function. I also have 2 plus 8i over n and a factor of 1 over n. For this first choice, I'm going to make x number I the quantity that I'm cubing. X number I will be 5 plus 2i over n. Thinking of that as a plus I delta x, you immediately see that a is 5 and delta x is 2 over n. Then at the end of the product, I have 1 over n, but delta x is 2 over n. 1 over n is half of 2 over n. It is half of delta x. B is a plus n times delta x, 5 plus n times 2 over n, which is 7. X number I is going to be 5 plus 2i over n. I have to figure out the value of this in terms of x number I. So I'm going to take this fact and I'm going to manipulate it until I get the I over n by itself. xi minus 5 is 2 times I over n. So I over n is xi minus 5 over 2. The reason that I want to know that is that this other factor, 2 plus 8i over n, is 2 plus 8 multiplied by I over n, which is xi minus 5 over 2. If you algebraically simplify this, this factor is 4 times xi minus 18. We now know all of the pieces that we need. I'm taking the limit of the sum of this number to the third power. That number was what I was calling xi. I'll have a factor of xi cubed. This factor is equal to 4 times xi minus 18, so write that in. And 1 over n was 1/2 of delta x. I now have my sum written in a format that I can identify as an integral. Limit of sum turns into integral sign. Xi cubed becomes x cubed. 4xi minus 18 becomes 4x minus 18. I still have the factor of 1/2, and the delta x turns into dx. You can use the associative law to write the 4x minus 18 times 1/2 as 2x minus 9. The integral that I would have to calculate is this integral. We know the limits of integration from this part of the discussion. This integral looks relatively easy. But as stated, there were two candidates that were obvious candidates for the xi. What if you made the other choice? I'm going to take the 2 plus 8i over n to be ci, which again we're choosing to be the right-hand end of the subinterval, xi. A would be 2, delta x would be 8 over n. B would be 2 plus 8 over n times I when I is n, which works out to be 2 plus 8, which is 10. At the end of the product, I have the 1 over n. Delta x this time, though, is 8 divided by n. So 1 over n is 1/8 of 8 over n. 1 over n is 1/8 of delta x. I do have one other thing that I have to be concerned about now. I need to write 5 plus 2i over n in terms of ci, which is 2 plus 8i over n. What I'll do is I'll take the formula for ci and I'll rearrange it until I get the fraction I over n by itself. So ci minus 2 is 8i over n. I over n is ci minus 2 over 8. The factor that I'm going to cube is 5 plus 2 times I over n, which is 5 plus 2 times I over n is ci minus 2 over 8. Then algebraically rearrange that to get c number I plus 18 over 4. This is the quantity that I'm going to raise to the third power. So limit of sum of the cube of this quantity we just figured out multiplied by 2 plus 8i over n, which we chose to be ci. So I'll just write the ci down. The 1 over n was 1/8 times delta x. This now looks exactly like the definition of an integral. It's the integral of the cube of x plus 18 over 4 multiplied by x multiplied by 1/8 with respect to x. The limits of integration, 2 to 10, were determined over here. Now, this is a perfectly nice integral on one level. It's just a polynomial, but it doesn't look nearly as nice as the other one did. In this problem, you are to decide which one of the two integrals looked easier and evaluate that one. This is a routine matter. Multiply the integrand out so that you can get it into the form that you can use our standard antiderivative techniques on. In this problem, we're going to take the region in the first quadrant below the graph of y equal 9 minus x squared and revolve it around the x-axis. We want to calculate the volume. We'll use the disk method for this. Since I'm revolving around the x-axis, I'll have a thin rectangle with horizontal extent delta x number I. The radius of the disk is the distance from the axis of rotation to as far away from the axis of rotation as I can manage to get. That's going to be the y coordinate on the graph y equal 9 minus x squared. I need everything in terms of x because I'm going to integrate with respect to x. So the radius is 9 minus xi squared. We're going to take pi times the square of the radius times the perpendicular height on the disk. We add up all such things and take the limit. Pi times the square of the y coordinate, the square of 9 minus x squared, integrated with respect to x. The evaluation of the integral is routine, so I don't see the need to go into any great detail. Lastly, we will revolve the same region of the xy plane, except this time it will be revolved around the y-axis instead of the x-axis. Notice this isn't the same shape as the previous one. We're not calculating the volume of the same thing two different ways. We're working two different problems. Since I'm revolving around the y-axis, my circles will be at right angles to the y-axis. The radius of this circle will be a distance measured perpendicular to the y-axis. I can be as close to or on the y-axis as I want. On the y-axis, x is 0, and I can be as far to the right as the x-coordinate on the parabola. Of course, since I'm going to integrate with respect to y, everything needs to be in terms of y. So on the parabola, I have to express the x-coordinate in terms of y in order for my integral to work out. Y is 9 minus x squared. Y plus x squared is 9. X squared is 9 minus y. Mathematically, that has two solutions, but we want the one that's not negative. We want x equal principal square root of 9 minus y. This is going to be the radius of the disk. Pi times radius squared times perpendicular height. Add them all up. Take the limit. Limit of sum is integral sign. Pi, radius is radical 9 minus y. One has to square the radius and then integrate with respect to y. Luckily, the radical sign goes away, and all I have to do is calculate pi times the integral from y equals 0 to y equal 9 of 9 minus y with respect to y. Evaluation of that integral is routine, so I'll leave that to the interested parties. Hopefully this helps a little bit in this entire issue. Everyone, have a good evening.